Hi, this is section 3.3, which is about derivative of trigonometric functions. So the objectives, of course, is to find the derivative of the basic trigonometric functions and apply some special trigonometric limits to calculate limits. We know that the function f of x is equal to sine x is a continuous function on its domain of definition, which is all real numbers. And the graph of sine and cosine are given below. This is like introduction. Now, what we have to remember for sine and cosine, that the derivative of sine is equal to cosine, but the derivative of cosine is equal to minus sine. So we need to remember these two rules for the sine and cosine derivative. So in general, sine and cosine, they switch each other for the derivative. The only thing that we have to pay attention that the derivative of cosine gives minus here in front of the sine. Okay, so let's do this example one as application. So if we have the function y equal to x squared sine x, and we want to find the derivative, okay, then I will compute here y prime. So y prime, this is the product rule. I will differentiate the first function, which is multiplied by second one. So the first one derivative is 2x multiplied by the second one without derivative, then plus the first one without derivative times the derivative of sine, which is cosine here. And we can keep the result like that, or take the common factor x, which gives 2 sine x plus x cosine x. So this is simple example. And also same for the try and check. I will differentiate the y. So 3 sine x, the derivative is 3 cosine x. And then minus 2 cosine x, the derivative will give plus, since the derivative of cosine is minus sine, so it's plus 2 sine x. And that's it. We keep the result like that. Now we go to the example number 2. So y prime is equal to derivative of ex, it's the same. Okay, so all the time here we apply the product rule, and I will keep sine as is. Then plus ex, it's like without derivative, times the derivative of sine, which is cosine. Finally, I can put ex common factor, so it's sine plus cosine x. Okay, so that's it for the try and check. Now we can, since we know the rule number one, rule number two, which gives the derivative of sine and cosine, we can find all the derivative of the other trigonometric function like tan, for example. So we apply the definition of tan here. Tan is sine over cosine, and this is the quotient rule. You remember the quotient rule? We make square the denominator, and then in the numerator, it's cosine derivative of sine minus sine derivative of cosine. And then we know that the derivative of sine is cosine, the derivative of cosine is minus sine. So just computing this and using the identities in trigonometry, so we find that it is equal to secant square. So this is like rule number 3, tan x derivative is equal to secant square. Next, we have this table that we can use when necessary. So the derivative of sine and cosine, we saw them in rule 1 and 2. The derivative of tan, just in the previous slide, secant square. By the same way, you can find derivative of cosecant. Cosecant, remember that it is 1 over sine. And here again, you apply the quotient rule to find that it is equal to minus cosecant multiplied by cotan. Derivative of secant, which is 1 over cosine, same thing. You apply the quotient rule and you find that it is secant times tan. And finally, the derivative of cotan, it's like this one. It's minus cosecant square x. So it's better to, of course, remember this table. If not, if you forget one of them, you have not to forget these two basic ones. Then all the others can be deduced from 1 and 2. Okay. Let's make an application of this formula. So here again, we will use the quotient rule. You see that f is like f over g. So f prime of x is equal to, first thing, when you have a quotient like that, put the denominator squared in the derivative. So 1, sorry, let's remove this. So 1 plus tan x squared. And in the numerator, I will write it step by step. So it's secant x prime multiplied by 1 plus tan x minus secant x multiplied by the derivative of 1 plus tan x. Okay, so here I will replace using the table. We saw that the derivative of secant is equal to secant x times tan x multiplied by 1 plus tan x and minus secant. Here it's only the derivative of tan, because derivative of 1 plus tan, the derivative of 1 is 0, and then you compute derivative of tan, which is secant squared. So again, we multiply by secant square x here, and we divide by 1 plus tan x squared. Now we expand. So we will have secant x times tan plus secant x times tan squared minus secant cubed. Okay, over 1 plus tan x squared. Secant is 1 over cosine, and tan is sine over cosine. So it's like sine over sine times secant square, this first quantity. Okay, so we can here put some factors, then use the identities. So it will be equal to, I will continue here. So it's equal to, I will put secant x common factor. So tan x plus tan squared x minus secant squared. All these divided by 1 plus tan x squared. And you see here, I will change just the color to make it clear. I have tan squared minus secant squared. What I suggest in general is to write the identity as you know in the lecture, then make the transformation of this identity. So we know that 1 plus tan squared x, okay, equal to secant squared x. So that means that when I put secant squared from this side, and I have to put the one in this side. So in total, it's like tan squared, another form of this identity, minus secant squared x equal to -1. Okay, so all what I have here in green here, I will replace it by -1, and that is my result. So secant x times tan x minus 1 over the denominator, which is 1 plus tan x squared. And that's it. We can stop here. The derivative is factored, and that's good for later use. Okay. Let me do the try and check example here. So we want to differentiate the first function, y prime. So y prime is equal to derivative of tan, which is secant squared. So we saw this. So here I will apply the product rule. This is my first function. This is second one. It's like you have f times g. So that's the product rule. And we know that derivative of tan is secant squared. And in the formula of the product, you differentiate the first one, you multiply the second one without derivative. And then you have plus. You do the opposite now. You keep the first without derivative. Sorry, here. This is theta. So tan theta multiplied by the derivative of sine plus cosine. This is sum of two functions, derivative of the sum. That means cosine theta minus sine theta. So we see if we have some simplification. If we don't have, then we keep the result like that. We can put maybe cosine and sine common factor. So separate, expand, and then put them in one expression times cosine and another expression times sine. If not, we can keep the result like that. Okay. So another way to see the result is secant square theta times sine. Secant square times cosine, that will give plus secant theta. And then tan times cosine, that will give sine theta. And minus tan multiplied by sine, that will give minus secant theta times sine square theta. Because tan is sine over cosine. Okay, so we see here, if we have some simplification, if not, we will keep the result like that. So clearly we can put, for example, this is not necessary, by the way, just simplification of the derivative. So I guess we can put these and these together and see if we can simplify. If we cannot simplify, then keep the result like that. So when we put these two together, we have a sign like a common factor. Clearly, we cannot do anything about what we have. So we will have secant square theta plus 1. This is nothing. We cannot remember the identity does not give secant square plus 1. Okay, it gives 1 plus tan square equal to secant square. So basically, we will be happy of this form. Okay, I will go to the next one. 2. So y prime is equal to, all the time here we have f times g. Okay, so product rule again. So cosecant x prime times cotan x plus cosecant x times cotan prime. And then remember your table and just put the result. Cosecant, the derivative of cosecant is equal to minus cosecant x cotan. So another cotan, here this first one is coming from the derivative of cosecant. So it will be cotan times cotan, so cotan squared. And the second one plus cosecant x times the derivative of cotan, which is minus cosecant square x. Okay, so in final you will have minus cosecant x cotan square x minus cosecant cube x. We can continue and work a little bit on this. So put minus cosecant x common factor. It will be common factor cotan square x plus 1. And cotan square x plus 1, this is 1 over, it's cosecant square x. Remember that we have 1 plus cotan square x. Cotan, by the way, is cosine over sine. So when you replace this definition, it will give like 1 plus cosine square over sine square. Take the common denominator, and then you will have cosecant square x. So this will be equal in final, since this between parentheses cotan square plus 1 is equal to cosecant square. So in final it's minus cosecant cubed x. Sorry, here there is a little mistake. So just we changed here they not 1, this one. So we don't need to go more than that. This is cotan square plus cosecant square. And we can keep the result like that. We don't need even this formula, because we don't have formula for cotan square plus cosecant square. And its factor is good, so we keep it like that. Okay, now we want to find the 27 derivative of cosine x. Okay, when we have to compute higher derivative, first thing is to make the first derivative. So we know that cosine x prime is equal to minus sine x. Then second, cosine x second is equal to derivative of minus sine, which is minus cosine. Then third, let's say third derivative with respect to x of cosine will be sine x. Since we have derivative of cosine is minus, with this minus it will be sine x. Then the fourth derivative of cosine x will be the derivative of sine, so it is cosine. And here we go back to the original function. Okay, so the process will be like with repetition after four derivatives. So it's like a periodicity somehow. After each four derivative, you return to the same function. Okay, so since 27 can be written like 8 times, sorry, so we said it's 4, so 6 times 4 That's 24 plus 3. So it's like you do the third derivative. All these derivative does not count because it will be returning to the cosine. And the third derivative will give sine. So the 27 derivative, d 27 over dx 27 of cosine will be equal to sine x. Since we will have this order 3 here, like the 27. Okay, same idea here for the try and check. So we will call these f of x and compute the first derivative. F prime of x is equal to the derivative of ex, it's the same, and derivative of sine, that's plus cosine. And next, the second derivative, f second of x is equal to ex all the time, minus sine x. So still here, we didn't return to the original function. So let's go to the third one. It's ex minus cosine x. Still, and the fourth one will give us ex, derivative of minus cosine, that's plus sine. And here is, it's exactly the function f. So the repetition will be after 4 times derivative. Okay. So since 33 is equal to the multiple of 4 is 8 times 4 plus 1. So it's like the derivative number 1. So f 33 derivative of x will be this one, like this one. So ex plus cosine. Okay. Now some rules for the limits coming from the derivative. Sorry. We have the rule number 4, limit of sine theta over theta when theta approaches 0 is equal to 1. This is coming from the derivative because you will write that the function is sine. Okay, so sine theta minus sine 0 over theta minus 0. When you take the limit, when theta approaches 0, this is exactly the derivative of sine taken at the point theta equal to 0. And what is the derivative of sine? This is cosine taken at 0, and cosine at 0 is equal to 1. That's why this limit is equal to 1. By the same process, you can conclude also this limit. And we can use these in functions. So these are now true for any function using sine x over x when x approaches 0. The limit is equal to 1, or the second one, or same as well for the second one. But here keep in mind that the limit is at 0, approaching 0. Look at this example here. We want to find limit sine 7x over 4x. When we substitute x equal to 0, of course, we will find that 0 over 0, this is indeterminate form. So we have to use the rule in the previous slide and write that it is equal to limit x approaches 0, sine 7x, and I need to divide by the same thing to use the previous rule. Since I divided here by 7x, so I will multiply to not change the expression, and don't forget that I have over 4x. Okay, this limit is known from the previous slide. So this is 1. And this, after simplification, will give, so this limit is 1 multiplied by 7 over 4. So the result is 7 over 4. That's this limit. Okay. Same idea here. Compute the limit x cotan x. When you replace x by 0, of course, you have problem with cotan 0, since cotan, remember that cotan is cosine over sine. So you cannot divide by 0. Okay, However, if we write this limit like x approaches 0, x times cosine x over sine x. And somehow we see that there is division of sine by x. I will write it in this way. X approaches 0, cosine x over sine x. And this x comes in the denominator here. So over x. And this limit is approaching 1. And this, when x approaches 0, this is also 1. So it's 1 over 1 equal to 1. And that's the answer for this. Limit cosine theta minus 1 over sine theta. Again, here when we substitute, it will be 0 over 0, so indeterminate form, but we use the two rules, 4 and 5. So it is equal to limit theta approaches 0, cosine theta minus 1 over theta, and I multiply by theta, divide by sine. Okay, I know that this quantity will approach 1 when theta approaches 0. And this quantity approaches 1 also when theta approaches 0. So the result is equal to 1. Sorry, this is, yes, this is approaching 0. So 0 times 1, this is equal to 0. Sorry. Okay, now try and check example here. So the first limit, x approaches 0. So I will put sine x common factor in the first, in the numerator. So sine x 1 minus cosine x over x squared. Okay. And I will also separate. So this is limit x approaches 0. Sine x over x, I will separate the x squared into x times x, and 1 minus cosine x over x. Okay, I know that this quantity approaches 1, but this quantity, somehow it's written like with minus, so it's minus cosine minus 1 over x, but it is approaching 0, so the result will be 0. Over the second one, limit x approaches 0, 1 minus secant x over 2x. Okay, I know that secant is 1 over cosine, so I will write it like that. X approaches 0, 1 minus 1 over cosine x over 2x. Okay, so it will be equal to limit x approaches 0, and I will take common denominator cosine x. It will give cosine x minus 1 over cosine x, and the whole thing over 2x. That I can write limit x approaches 0, cosine x minus 1 over x times 1 over 2 cosine x. Okay, and now I know that when x approaches 0, this quantity goes to 0. And this quantity is well defined since it will give half. Okay, so 0 times half, this is equal to 0. This is the end of lecture 3.3. Thank you so much.